Okay, hello everyone. I propose to start this webinar. So thanks a lot everyone to being with us today for a little less than an hour. Just before beginning, I would like to explain you that you can, during the webinar, ask any question. You have a chat on the GoToMeeting tools, so you can ask any question during the webinar, and we will answer this question at the end. So the main purpose of this webinar is to present the AWS IoT ExpressLink solution for your connected products and what answer ExpressLink present the engagement on communication on IoT project. We will be three to speak today at this webinar. First of all, we will have Thomas. Thanks, Thomas, to be with us today from AWS. I'll let you present yourself quickly. Thomas?
Yes, thank you very much. Thank you very much for giving me the opportunity here today. So my name is Thomas. I'm a specialist solution architect for IoT here at AWS. And I've been leading our training and enablement efforts regarding the ExpressLink and the connected products on the IoT world over the last year. So I'm really happy today to get the opportunity to present the ExpressLink, present the broader AWS IoT services, and discuss a couple of interesting use cases that you probably have seen and that hopefully a couple of our viewers today are also building in terms of connected products, connected devices, and interesting applications of these services.
Thomas, David, sorry.
Hello, everybody. So I'm David. I am a CTO of for IoT solutions in Smile. And that's all for me. And
I'm Cedric Kravalek, so I'm responsible of the cloud and IoT offer inside the group Smile. So the agenda of this webinar, we will have a small introduction about our company, what we are doing on IoT and what we are doing with AWS technology. After that, David will take time, 10 minutes, 15 minutes to present you what is the challenge in IoT with connectivity to introduce after the solution of AWS by Thomas, who will present us IoT ExpressLink. And after we'll have two wonderful demos, a remote demo by Thomas, one on the sensor and another one on digital twin. And like I say in the introduction, you will have question and answers at the end of this presentation. So let's start quickly to present Smile Company. So Smile Company, it's a long experience company. So we have near 30 years old now. We are 1,800 people, mainly in France, and we start going in Europe, in Germany, in Switzerland, and we'll go forward in the north of Europe later on. And we are a consulting company with a very strong DNA on open source, with a lot of on open source, a lot of contribution. And we're specialized to help our customer to digitalize their process in all the industry, mainly. If we can go further, David. So today we will focus in a specific division. We have a dedicated division where David is the CTO. It's a division dedicated to embedded system and IoT technology. So we do a lot of development on connected objects, and we help customer to develop this object, put software in it, and develop all the connectivity and solution around it. We are a big partner of AWS since more than 7 years now, and we have a specific service delivery partner on IoT technology since 2008, and we are one of the biggest IoT partner in France with AWS technology. And we choose, just to make this introduction is very important. Why did we choose this technology? First of all, when we do a lot of embedded system, open source embedded system, we work a lot on FreeRTOS, and of course now FreeRTOS in the AWS area. So it was natural to work with AWS on that. And because also, if you look at the market, what's AWS is doing now is really great. They develop a lot of solutions to simplify a lot of the process when you do an IoT project. And they are the more advanced company around the world with a lot of technology based on open source and to industrialize IoT project and connected project. That's why we made the choice. David, you can. Thank you. So by Smile, we work a lot on digital working in the IoT area. So it's very important to know when you do an IoT project, it's most of the time a very impact project on the company. It could be to have a better process inside the company to develop new business model, new digital services around your product. So you need, when you implement this kind of project, to have the knowledge of a lot of technology, embedded technology, cloud technology, data technology, digital technology. And the strength of Smile is to have a division for all this area. So when we work with company, we help big company on IoT project, we help them in all the value chain of the data all around the project. And we work with AWS technology in all this area. All the value chain AWS have their very good technology to help you on your project. You can go further. And this was just a slide here to explain you that we work also in a lot of embedded open source technology, FreeRTOS and others. So we have a high expertise. We have more than 150 people dedicated to this division. And we are quite one of the leaders in France on embedded system and open source. And to finish, on the last slide, is just to present you that we contribute a lot on open source development at the open source community. This is very important for us and for our employee. And we do also a lot of white papers. So we invite you to go on the website and you will see the last one we just write. Based on IoT project and AWS technology, but we work also and we made some white paper on security connectivity, and we do a lot also of webinar like today. So Smile is very pleased to work with AWS, very pleased to present this new technology. It's very interesting. You will see that with Thomas, and I'll let you, David, go further on the presentation. Thank you very much.
Thank you, Cedric. So at this point in the presentation, I'm going to talk about some of the challenges we face or some of the questions we have to ask ourselves when designing a connected device. And this the few slides I will share with you is a kind of general introduction to the solution Thomas will present later on. Some of this points are well known and classic, and others are current, a daily reality and sensitive. Indeed, cyber security issues are now a daily reality. The point we will discuss are bandwidth, system security, upgradability or scalability of devices, and compatibility. I will finish by presenting a few ways to focus on the business application, and then I will hand over to Thomas, who will present the solution. So, one of the first challenge when we are developing an IoT solution deals with networking. The subject concerning those type of communication and the type of connectivity to be used for such a system is very classic and but essential. And I think that the vast majority of you are familiar with those different types of communication. But anyway, I will present them very quickly. We can classify them according to the type of connectivity. And first, we have the short distance networks, for which the range goes from a few centimeters to a few meters. Among those networks, you will find BLE, RFID, NFC, and the other category is the long distance network, which range from a few meters to several kilometers. And we find in those categories classic network Wi-Fi and Ethernet, often used as gateways networks. And then we have networks more oriented towards IoT solutions, towards IoT applications. Those are LoRaWAN, NB-IoT, and LTE-M. LTE-M and NB-IoT are derivatives of 4G networks, and we have the 5G network. Each of those networks types are traditionally compared according to their power consumption, throughput, range, and other criteria. And those criteria are focused on material or low level. And then after having chosen one of these families, we must think about the integration of communication protocols based on those families. Those more high-level criteria are security, upgradability or scalability, maintainability, and many others. But those are topics I will cover in a few slides. But we can see that we have many possible choices, even among the same family of network. The first challenge I will address is the field of security. This is really now a very important challenge, one of the first we have to address when designing such a solution. And this field has long been neglected. So that must not be the case now. We are seeing the arrival of a set of standards, whether European standards such as the EU Cybersecurity Act or not, and those standards will bring constraints on the manufacturers. The system, there are several aspects of the IoT system that need to be decided and specified before work begins. We have already mentioned connectivity, but it is also necessary to define the life cycle of a connected device within the system. We must define the hardware resources needed to be able to integrate good practices and in terms of cybersecurity. And we must define and specify the security chain before the project starts as well. The life cycle can be viewed as follows. You have a first phase, which is the provisioning phase, then the commissioning or the enrollment, then the real life of the device, I would say the activity of the device, and then the decommissioning, what we do when the device is old and doesn't work anymore. Depending on the stage of its life cycle, a connected device will need to request a certificate in order to be authenticated, on the IoT platform. It will also need to renew its certificate, and finally, this certificate may need to be revoked in case it has been compromised. All those security aspects requires the implementation of a set of technical processes and business processes, in fact. And all those aspects must be fully integrated into the strategy into the corporate strategy. The technical attributes involved in the safety of a device are the choice of algorithms for authentication and encryption, the choice of a set of cryptographic suites, the ability to generate secrets in the device, the ability to collect a new certificate, to ask for the rotation for the renewal of a certificate. You must embed protocols for exchanging and issuing certificates, etc., and etc. All those software techniques are quite hard to implement, and moreover, they are quite greedy in terms of hardware resources, in terms of CPU and more RAM and flash. Thus, we must decide on a compromise between hardware, software, and security level. It would be interesting to be able to delegate those kind of choices in order to get rid of some constraints. For example, when you have only 2 kilobytes of reception buffer on the microcontroller, it's difficult to handle algorithms with, for example, RSA 4096 bits long case. You will be constrained to choose another algorithm, for example, an elliptic curve algorithm, or to choose another RSA algorithm, for example, 2048 bytes. But if it suits your needs, it's okay. But you don't have the choice in this case. So the delegation of those technical issues can be maybe a nice solution. I will continue with a little overview of scalability or upgradability. Maybe upgradability is a better choice. The upgradability of a connected device and compatibility between protocols. Why do we need the ability to upgrade a connected device? Of course, we need that in order to correct some defects, to correct some security issues, and to upgrade a device for adding new functionalities. The first two reasons are obvious and of course essential, and require the implementation of data transfer protocol from the IoT platform to the connected devices. Adding functionality may require updating the application, the firmware, third-level libraries such as the MQTT client if you use an MQTT protocol. One can imagine a scenario where some devices are running version 3 of the MQTT protocol, and new devices are running version 5 of the MQTT protocol. We would then like to update the MQTT client version of the older devices to take advantage seamlessly. This word seamless is important for example, for taking advantage of the reliability improvements of the protocol without having to update the embedded application. We would also like to benefit from new protocol services, such as, for example, shared subscription, non-local publishing, or others provided by a new version of this MQTT client of the MQTT protocol. And ideally, we would like to have those new services available through, for example, an API or introspection. We can as well imagine being able to use either an MQTT client or an AMQP client seamlessly as well, because we don't want the embedded application to depend on the underlying protocol. It's just the embedded application just needs to send a message. In both cases, having an abstraction layer of the messaging protocol is interesting. Then dealing with I finish with a few things about standardization. The IoT landscape is not yet standardized like other domains, such as automotive industry, for example. There is no cross-cutting standard among all the domains of IoT. The existing protocols are still quite numerous, and some standards are linked to an emerging domain. For example, the Matter standard for the home automation domain, but this is the standard for just one domain. Thus, uncertainty reigns, and how we show at the time we design an IoT system that the chosen protocol is the right one. It would be then comfortable to have at our disposal a way to dispose of another protocol, of other protocols in a transparent way. So that leads to my last slide, which is, can we simplify the development of and the life cycle of our IoT device? We have talked a lot about the technical aspects to implement, but we didn't talk about the business application, or very little about the business application embedded in the device. And the value of the device is its embedded application, its business application. So why not encourage some abstraction or delegation so that we can focus on the design of the business application? We can abstract some software layers. We can abstract the communication protocol. We must keep a kind of coherence in the system. Of course, we cannot change BLE communication protocol with NB-IoT. This has no sense. but we maybe choose between LTE-M and NB-IoT seamlessly. Why not? We would like to abstract the so we would like to abstract in some extent the underlying medium of communication, but keeping a kind of coherency. Then we can maybe abstract as well the hardware provider. Why not? We would like as well to delegate all other technical parts. For example, we would like to delegate hard things to do, such as management of secrets and management of certificates. We'd like to delegate the management of certificates rotation, the maintenance of program libraries. We would like to maybe as well delegate some high-level event messaging queues. We would like to delegate inbound and outbound message buffers, so we can have a certain amount of messages ready for reading with our embedded application. We would like as well, that's the point I was talking about a few seconds ago. We would like, in fact, to delegate hardware resources. It is therefore, it may be therefore possible to entrust a kind of module with resource-intensive services such as cyber security management, and then have the choice to choose the right suits for cryptography. And then this is the point where I will leave the floor to Thomas, who will present more, maybe technically, more precisely, a module, a kind of design that includes some of the point I did mention above. So Thomas, I'm sorry, I touched a few things that you are going to talk about as well. So Thomas, I leave you the floor now.
Yeah, thank you very much. I think you touched on a couple of really interesting points here, and let me also kind of push on those points a little bit more in terms of challenges and, well, what we now call quick, easy, and secure building of connected products using AWS IoT ExpressLink. So I also brought a couple of slides with me, a couple of those challenges, David, that you mentioned. Kind of you will find the same ideas and the same concepts now in these slides as well. But let me just walk you through the key points here, what we at AWS think connected products should be built like, and how easy it can really be, how quick it can be, and most importantly, to stress one of your points, how secure it can be. Right? You mentioned a lot of interesting points around certificates and cryptographic keys and 4096 bits of ciphers. Why does every customer, why does every equipment manufacturer have to reinvent those things? Why don't we as AWS now solve that challenge once and then offer you like a fully managed package that you can make part of your connected product to, well, take care of all of those difficult bits that others also need to solve, because those are not really something that sets your product apart, right? If you build a connected washing machine, well, your key focus should be on the washing of your clothing. It should not be on spending months and months or years and years building a secure connectivity module. So that's really something that you solve once, and that's what I'm going to introduce here now. We already talked about use cases and different ideas. So just as a very high level thing, what we see at AWS in terms of customer requests, customer opportunities from connected appliances, so the traditional smart home or smart industrial equipment, for monitoring, sensing, actuating. So we also talk about Industry 4.0, automation, manufacturing equipment. But this really then extends to a very broad range of use cases and ideas from medical equipment, agriculture, general purpose resource constraint devices. So the field is seemingly endless. And the connectivity is one of the key elements then that enables us now in this internet age that we have now entered over the last maybe 20 years. So building a secure connected device, that's one of the key challenges. And that often requires specialized competencies. So of course, today we have the experts also here in the room. But what if you actually could simplify that even further? If you don't want to deal with all the third-party libraries and the dependencies, thousands and thousands of lines of code that you need to bring into your product, into your firmware, just to speak in a secure way with the cloud or with any other endpoint on your network. And at AWS, we typically call that undifferentiated heavy lifting or undifferentiated work, because, well, everybody needs to build the same kind of thing. If they want to connect the product, they need to solve the challenge of security. They need to solve the challenge of connectivity. And they need to solve the challenge of integrating that all into a firmware, into a product, so they can make use of all of those new fancy features. And that leaves a lot of room for mistakes and security vulnerabilities to creep into your product. So this is a lot of additional maintenance effort, additional maintenance burden, where you need to maintain, develop, update your product over the next 5 years, 10 years, 20 years, depending on the industry that you are trying to build your products for. In a traditional system architecture, now this is just a representative illustration here, what we commonly see is that you have some kind of host processor. And in this host processor, then you have a number of different elements, so to say. Of course, the key element here is your application. Well, that's what your business, your product is actually about, right? Controlling the equipment, sensing temperature, sensing humidity levels, displaying information on a LED board. That's your application, and that is what your product is all about. And that should set apart your product from your competitors. But you also need something like an IoT library to talk to the AWS cloud, where you hopefully run your IoT services. And with this IoT library, well, you need a radio library to talk to some kind of wireless module, right? If it's a Wi-Fi module, a cellular modem, maybe LoRaWAN, maybe Bluetooth. So you probably have some kind of wireless module, and that requires a radio library to interface with that peripheral. And as we now already talked a couple of times on the security level, we want a hardware security element that can store our keys in a secure way so that we don't lose our certificates, that we can rotate our secrets in a secure way and store them without being able to be tampered with. So all of those elements here, you need to manage as part of your firmware because that's your host processor. So all of those things need to be baked and merged into a single binary, into a single firmware. And that's also what you need to maintain going forward with supporting the life cycle of your product. 5 years, 10 years, 20 years. You need to keep updating those libraries. If there is a new TLS standard, TLS 1.3, as the most recent standardization from the RFC came out, you are now responsible to bring in that new code, audit the code, make sure that it matches your security posture, and then deploy and roll out that new protocol specification as a firmware update. So you can see a lot of different things are happening that are your responsibility. And that's where we as AWS thought, okay, we can definitely help in this area. Let us introduce AWS IoT ExpressLink. And with ExpressLink now we are clearly separating those two key concerns. The first concern obviously is your application. That's what is setting apart your product. So you focus on the host processor and you focus on your application. But you don't really want to spend time and effort and maintenance cost over the next years to focus on those other things. And that's why we are now introducing the ExpressLink module. So this really is a dedicated chip, a dedicated module that you make part of your product. And it encapsulates all of those key elements that I just talked about. It contains a hardware security module, so you can securely store your cryptographic key material. You can have your certificates, you can have encryption and signing operations, all part as the value proposition from this ExpressLink module with the built-in secure boot, trusted storage as a hardware security module right in the ExpressLink module. The ExpressLink module is also a specific connectivity solution. So it already has a built-in radio library because the module itself is the radio. So you don't need to mess around now with implementing a certain library for a certain Wi-Fi standard or for a certain cellular LTE standard. It's all part of the ExpressLink module. And inside that module, well, the radio talks to itself basically. And lastly, of course, the IoT library. So in our case with AWS, we are running AWS IoT Core as a fully managed MQTT broker. So the AWS IoT ExpressLink module directly communicates with a built-in IoT library over MQTT to the AWS cloud. So you can securely and easily integrate all of your things, all of your devices over MQTT into the AWS cloud. So how does that look like from a communication perspective? Now we have different modules, different elements here in our architecture. So I already introduced the microcontroller and the host processor, as we also sometimes call it. So this can be a small embedded device like an STM32 or like a PIC microcontroller. So this can really be a very low power, cheap 8-bit microcontroller solution. And the only requirement or the only needed peripheral is a serial interface, a UART interface. So you can then communicate with the AWS IoT ExpressLink module. So both of those elements, the microcontroller as well as the IoT ExpressLink module, they are part of your product. So they sit on the same PCB or they sit inside your same device. Maybe it's a daughter board, maybe it's a part of the same assembly. But those are in close proximity to each other and they communicate over a serial UART interface. And then the ExpressLink module, that's now the joker basically to get you online, to get you connected to the AWS IoT Core broker. And for that, we currently support two different types. One is with Wi-Fi modules, and the other one would be with cellular modules. So cellular in terms of 4G, cellular LTE modules. But both of those provide general purpose TCP/IP protocols. So we already make use of a mutual TLS system and then MQTT on top of that. So now you have your AWS IoT Core, and from there you can send your messages to all sorts of other IoT services and features that we have part of the larger family. For device defender purposes, if you want to have more introspection about the security, through state machines and analytics with IoT events and IoT analytics, or if you are in an industrial world with IoT Sitewise, you can directly ingest data and also manage your devices with firmware updates, software updates, and other processing jobs that are typically part of your product lifecycle for device management. But that's not everything, right? You can also reach out through IoT Core, through the built-in rules engine, to all the other AWS services that we offer. So you can directly ingest data into Amazon TimeStream, a time series database. And we will do that in one of the demos in a couple of minutes. So IoT Core provides many different rules and integrations to directly ingest data into many different AWS services. And that really opens the door then to connect and integrate your edge devices into your larger AWS cloud environment. If you want to use Kafka for message streaming, if you want to have a function for data processing with AWS Lambda, or if you just want to have a data archive, a telemetry archive, you can store your data directly into Amazon S3 without actually having to write a single line of code. So all of that can be fully built in and integrated with the AWS IoT Core and the rules engine to branch out to those different elements. So we heard a lot about the challenges. Well, the benefits then are kind of the inverse of the challenges. It's a quick solution, it's an easy solution, and it's a secure solution. You don't need to download and install thousands of lines of embedded C code. You don't need to reinvent the wheel about how do I store secure certificates, how do I generate them. All of that is built into the AWS IoT ExpressLink module, and it helps you out of the box to get all of those things at scale built in and protected. Now, I talked a couple of times about modules and Wi-Fi and cellular modules. We're actually partnering with our hardware vendors, with the actual module manufacturers. So at AWS, while we are not in the business of making custom silicon for embedded devices, and that's why we have partnered up with folks like Espressif, Infineon, Realtek, Telit, and u-blox. And all of those partners basically took one of their modules, one of their radios, and implemented the AWS IoT ExpressLink standard or specification. And then they provide the same application interface, the same API, the same command structure. So you can easily swap and change out from one product to the next without actually having to touch a single line of code. I mentioned commands, the application interface. So all of that happens over the serial UART interface. And that's where we traditionally see AT commands. And ExpressLink offers you exactly that. It offers you a set of AT commands. And here I've just pulled out, I think, the 5 most important AT commands, and pretty much also the 5 that you really need. All the others are a little bit of helpers and additional features, but these are the 5 key commands, and those are essentially 5 lines of code that you need to write to get your product connected, as the first command here suggests, right? You just say AT connect, and then the module does all the heavy lifting for you. You don't need to set up a TLS socket, and you don't need to mess around with buffer allocations. You just send AT connect to the module, and the module will figure out, what do I need to do? Do I have a SIM card? Do I have a Wi-Fi connection? Do I have something else? How would I set up that? So that's all handled by our hardware partners and by the custom firmware that is running on those modules. Then obviously you want to configure an MQTT topic. So here you can just say atconf for configure, and then you say, okay, my topic number 1 is wind turbine / a serial number / telemetry. And from now on, topic number 1, that's my MQTT topic that I, for example, can subscribe to. AT subscribe, and the index 1 here indicates that it's again talking to the topic number 1 that we just created. So AT subscribe, right? It's that simple. You don't need to allocate any special buffers or sockets. Just send the AT subscribe command, and once the message is available, once you have received something, it's actually buffered on the ExpressLink module, and you can simply retrieve it with an AT get command. And then the command simply returns a message to you that says, okay, so the command was successful, and here is the JSON message that you received. And the same thing goes also in the opposite side. If you want to send something, it's as simple as just saying AT send, and you give it a message payload, some kind of JSON element with your sensor data, temperature, humidity data, pass that into a JSON string, and just send it out to the ExpressLink module. And the module takes care of doing all the MQTT work, all the encryption work on TLS, and transmitting that out to the cloud. Now, in the last couple of minutes, I want to briefly introduce you to two live demos that I have here. And the first demo is exactly about that sensor telemetry use case. So imagine in this use case that, here I call it the demo badge, and that's actually one of the devices that we have built internally to, demonstrate the capabilities of ExpressLink. So this is just a nice kind of conference badge type of device. It has a couple of buttons, it has a couple of sensors, and most importantly, here at the top, it has an ExpressLink module. So this is an ExpressLink module by Espressif. So this is a Wi-Fi module. But as I mentioned previously, all the modules speak the same AT command set. So if you want a different one, just make it part of your product. And with that module, we have different temperature sensors, humidity sensors, and an ambient light sensor. And all of those sensor values are collected by our host processor. So I have maybe 10 lines of code to use I2C and other peripherals to ingest those sensor data and then transmit them to ExpressLink, which is then forwarding all of that data directly into IoT Core. And from there, we go into a time series database in the AWS cloud, which is Amazon TimeStream. And from that database, then we can fetch the data and visualize the data in a Grafana dashboard. So let me actually briefly jump over here into the browser. So you should now see the AWS console browser. And here I have something that is called the AWS rules engine. And in that rules engine, I have one integration created that exactly takes those sensor data elements. And if I go into the details here, I see that, essentially we are taking all of the sensor values that are coming from my device, and I'm simply creating one action to insert all of those data values, data packets into TimeStream. And from TimeStream, then we can visualize all of that data into any type of visualization that you want. So this is just a use case. You can see the ambient light, humidity, and temperature. The charts are already going up and down a little bit since I started handling the device. So for example, if I take a flashlight here and I shine it on top of my sensor, you immediately see the ambient light spike up. So we have near real-time data ingestion. Grafana is actually the slowest element here because it just updates once every 5 seconds, but I can ingest data at a much higher rate than that. The same also works with the temperature and the humidity. So if I press my thumb on one of the sensors, you should also see that, obviously my body temperature is bringing up the temperature of the sensor. It's getting more humid due to the moisture on my fingers. So you again see this as a very quick and fast way of sending that data to get a live response of those different elements. Now let me jump back to the second use case that I've prepared. And the second use case is around digital twins or digital shadows. So those are two technologies that go hand in hand with each other. And again, very similar system that we had in the previous slide. So again, we have peripherals and different sensors. But now the digital twin and the digital shadow, they're all about sending commands, actually changing the behavior of your device. So now we are making use of something called the device shadow feature inside the AWS IoT Core system. And this device shadow can then be manipulated, or it can simply be viewed from a companion web app. So this is now just a demo again, could be a smartphone application, could be a dedicated website as I have built. But this web application companion app allows the user to manipulate and view the device shadow. And all of the changes that you're making to the device shadow, they get sent and migrated down through ExpressLink into your host controller to then influence your actual hardware that is on the device. So if I jump back here to our demo operation, then we can view the digital twin that I have built for this device. So again, it's the same device, it's the same thing, but now it's a 3-dimensional object. And that's the whole idea behind the a 3D digital twin. So this really is a 3D model. I can rotate that with my touchpad here. I see all the components that are on my display. And on the right-hand side, you can actually change and see different sensor values. So the easiest probably and the most visible one is in the center of the demo badge, you have a display here, and that's also visible here in the digital twin at the moment. So it's displaying a nice AWS bear, and we can simply change that from the browser, right? I say, okay, I don't want the bear, I want to see a toy. And within seconds, that configured requested change information is sent to the device. The device is reconfiguring itself. So the device knows, oh, I should be displaying a toy. So the device will do that. And then it will acknowledge that back to the cloud. So that's why you see kind of a 1 second delay, because it's first sent to the device. The device is acknowledging that and then relaying back to the cloud that, yes, I have successfully changed the configuration. So for example, if we now go back to employees, first it is a requested, a required state, and then that is acknowledged back to the AWS cloud. And you can do that with all sorts of things, right? Imagine motor control, imagine an RPM speed or some LEDs. So for example, on the back side, we have a nice set of color LEDs. At the moment, they are all black here. But if I change a single value to a bright red, that should light up within a couple of seconds, and you can actually change live the color to any color that you want. Or you can simply use a nice rainbow color effect, and then all of your LEDs start lighting up in all colors of the rainbow. So that's the digital twin and the digital shadow that helps you basically manage the physical state with the cloud representation of your device and of your utilities. And those were the two key demos. Lastly, I just want to conclude basically here by giving you a couple of links and resources. You can use the QR codes here. So the first one is the Programmer's Guide. And the Programmer's Guide, well, that's the documentation, the API specification for those AT commands that are shared earlier. I only showed you the 5 most important ones. There are a couple of extra commands in there that you can use to really fine-tune the system, but that's an easy way to get started. The second link here, the device catalog, that's where you actually find all of the provided vendors and hardware partners that already manufacture AWS IoT ExpressLink modules or even development kits, right? So all of our partners, for example, we have a development kit here by uBlox. So this is a cellular module, and that's a development kit. In an actual product, well, obviously you need an antenna, but in the actual product, you only need the chip itself here. So this is the only chip that you need. All the other components around here are just for development and testing purposes. And pretty much all of our ExpressLink partners make modules like this, right? So this is the same module that I previously used on my demo badge. This is the Espressif Wi-Fi chip. That's also part of my demo badge up here. But this is the dev kit version that you can buy online and get started exploring and playing around with AWS IoT ExpressLink. And with that, I think I'm handing it back to David for maybe some questions and answers.
Thank you very much, Thomas, for your always very nice demonstrations and very clear presentation. So if anybody has any question, I don't see any question in the chat. Everything seems to be clear.
That's the nice thing about AWS IoT ExpressLink, right? It's quick, easy, and secure. So there are no open questions. So everything answered, which I think is a perfect.
Nice demonstration.
Yes. We do have also GitHub resources available for sample code. We even have sample hardware manufacturing files. So if you want to build your own device, you can easily start with our Gerber files, our schematic files. for KiCad or for any other application. So you can actually prototype your own connected product in, I would say, a couple of hours. It doesn't take more time than that. You just need to find the right footprint for your component. And then within a couple of minutes, you have the PCB ready to be ordered from one of your online PCB manufacturing houses. So that's super simple. And that's also how I got started, basically, with building this demo badge device. So this was a demonstration device as well, right, as a dev kit. But compared to the dev kits from our partners, the demo badge has, well, a couple more interesting features: buttons, LEDs, temperature sensor. So that really gives you the look and feel of how would an actual product behave. So you can then think about more of those advanced use cases, like the telemetry use case that I presented, or the digital twin automation. Let me see. I see one question here. Can I find ExpressLink devices using STM32 microcontrollers? So STM32 is a microcontroller, as you correctly mentioned here. So the only ExpressLink devices that we have at the moment are those development kits. And those pretty much come, well, only with the ExpressLink module itself, right? So this one, for example, that's the Realtek module. And it has a very similar form factor to the Espressif module here on this side. And both of those modules come in a very traditional Arduino Uno Shield form factor. So if you find an STM32 microcontroller in that Arduino Uno Shield form factor, you can simply plug on top one of the ExpressLink development kits and kind of have that as a nice integration. So, for example, here I have a traditional Arduino, so that's the 80 mega chip. And the other module, well, it simply plugs on top of that, right? So you have a nice fully integrated connectivity solution with the ExpressLink module, and underneath you have your microcontroller. We have another question. Do you know some AWS clients using ExpressLink in production? Yes, I do have a couple of customer references. Unfortunately, we didn't have time today to walk through them, but you can find the customer references on our website. It's the second link I think I had on the slide. It was aws.com /IoT ExpressLink. So there you find a section called customer references with a couple of interesting quotes and use cases and other ideas on how our customers are using AWS IoT ExpressLink.